Alright, no BS Unity tutorial. We're making a top-down arcade player movement controller. If this is something you want to make, let's just get straight into it. If you don't know how to set up a Unity project, look elsewhere. Not doing that here. We're starting with a completely blank Unity URP project. Alright, let's set up the scene. First, make ground. Second, make empty player. Third, empty child. Fourth,
Bean.
fifth, beautiful pair of sunnies. And then if you want, just make him a prefab or something. Alright, now we have this little guy. Make a script. Call it what you want. Mine's going to be called player controller. Alright, first, add these variables. I'm making them all serialized so I can set them in the inspector. We want a camera, a layer mask for our ground layer, a float for rotation speed, and a player visuals game object reference. Let's start with rotating our player using the mouse. Make a new method called rotate player. We'll start by creating a ray from the camera through to the mouse's position on screen to find where it is in the 3D world. Next, we cast that ray into the scene, and if it hits something within 100 units that's on the ground layer, it saves that information to the hit parameter. Then we want to find the direction from the player to the point on the ground that the ray cast hit, and flatten that direction to stop any vertical rotation issues. Then, if the rotate direction isn't too small, i.e. the mouse isn't directly on top of the player, we create a Returnian rotation that faces the look direction that we just created. Then we smoothly rotate the player's visual model towards that target direction using slurp with a speed of roughly 15. You can see how this works for you, play around with it. Cool, then just set up all your variables inside of the inspector and give it a test. Cool, you can now rotate, so let's get on to movement. I'm going to be using the legacy input system here, but I'll make a video on doing this exact setup, but with a new input system at some point. First, add another variable called move speed and set it to 3. Again, do what you want. Then make a new method called player movement and add 2 local floats for horizontal input and vertical input. For my case, as I want an arcadey feel, I'm using getAxisRaw, which only supplies input values of -1, 0, and 1. Now we want to calculate the direction to move by combining the forward, back, left, and right input based on the player's current facing direction, and then normalize it so that diagonal movement isn't any faster. Then we move the player in that desired direction, scaled by the move speed and time.delta time to make it frame rate independent. Alright, so now give it a test, and now you should be able to look and move in the direction where your mouse is on screen. Alright, now we need to think about collision, because currently we'll just morph through shit. So let's fix that, it's real easy. For my own sanity and the sake of keeping stuff relevant together, we're going to move the collision onto the parent object. Remove the collider from your fucking cool ass glasses, and also remove the capsule collider from your bean. Then select your parent player object and add the capsule collider. Okay, now smack a rigid body onto it, set interpolate to interpolate, collision detection to continuous dynamic, freeze position on the Y, and freeze rotation on the X and Z axis. Alright, we're not done yet, because you'll see if you playtest it now that we have a real big problem where if we, well, one, we still go through the cube, and two, you'll notice that then we keep our velocity and we'll just be sent off at a continuous pace in a certain direction, usually the opposite direction. So let's fix this up now. We're going to need to rejig our script around a bit. Okay, so add 2 new variables, a rigid body called RB and a vector3 called current input. Create a new method called store input and move your horizontal and vertical local floats into them, and then below that set the current input to a new vector3 passing in these values and normalizing the result. Then inside the player movement change the transform.position line to moving with the rigid body directly instead. And to stop any drifting, if the current input vector is equal to 0, we set the velocity of the rigid body to 0, and that will stop the drifting issue. And to finish up, put the store input method into your update function, player movement into a fixed update, and then create a start method to get the rigid body component from the player. Alright, so for this example, we're going to stop there. I'm going to make a future video expanding upon this, so the next video will be switching out from the bean to an actual player character, adding in animations, because like you're not gonna make something cool without that. Really, it's just not gonna be that good. So yeah, if you want more videos like this, just subscribe and all that.